at the point in our semester. We are not covering any more complete chapters. So in chapter 6, we're going to do 3 sections. Chapter 7 we'll do a couple, and chapter 8 there's like 1. So we are really close to the end. Chapter 6 comes down to knowing your unit circle. If you know your unit circle, this stuff is really easy. It's a lot of what we've already been doing. If you don't, then you probably want to refresh yourself on that. So either being able to fill out a unit circle, and that might be the easiest strategy. You know, I always have blank ones before every test and quiz, so you can practice filling those out. I've got them sitting on my desk if you need one to practice. You might want to pull out a copy that you could have to look at today, if that might help you. You should have multiple ones we've done together in class. So that is what we're going to come back to in this. The first part of this section is talking about the inverse trig functions, and there's a lot of information here, but I'm going to talk about it, but I'm going to really highlight. You're not going to have to regurgitate all of this on a test. There are a few key things that we need to get from this, so I'll make sure and stress those things along the way. So when we're starting out, we're going to be talking about inverses. We did inverses back in college algebra or pre-calculus algebra. You did them in algebra 2. And at that time, we learned that not everything has an inverse. In order to have an inverse, it has to be a one-to-one function. So a one-to-one function is a function where y never repeats. If you remember when we looked at graphs, we said, okay, if it's a function, it passes the vertical line test. If it's one-to-one, it passes the horizontal line test. The y value can't get repeated if it is one-to-one. So the next little box that I have on there, I actually state the horizontal line test. If we think about, like, we've graphed our trig functions. If I took the graph of sine, is this a one-to-one function? No, it fails the horizontal line test. We hit the same y value more than once. What if I drew something like this? Would this be one-to-one? Yes, because you never hit the same y value more than once. If a function is one-to-one, then it has an inverse. And we can find the inverse by flipping x and y. So it's basically, that's the definition that's given in your book, but it's easier if we just think about it. We flip the x and y. Now when you flip x and y, then your domain and range change rules. So back when we did these in college algebra, we always had to give the domains and ranges, and we said the domain of the function is always going to equal the range of the inverse, and the range of the function equals the domain of the inverse, because the x in the original becomes the y, so the domain becomes the range, and vice versa. Looking at a graph, they are symmetric across the line y equals x, because to find an inverse, you just flip x and y. You let those things replace each other. So these are all good points that we need to talk about if we're going to be looking at inverses. In college algebra, we found inverses all the time, and it was like a 4-step process when we found the inverse. And the first step was to change your f of x to y, so that you had y equals something. Then we had to switch the x and y, solve for y, and then at the end we changed our y to f inverse for the function notation. Everything that I've talked about so far, yes, it's important, but it is not my emphasis here. This is just kind of a recap on things we've learned about inverses before. We're going to talk about the inverses of our trig functions, but we're really not going to go through this whole process of finding the inverse. I'm not really going to be asking you questions about the domains and range and things like that. We just have to kind of understand what an inverse is. Now, we have to think about the trig functions are not one-to-one. Okay, I already drew the graph of sine up here, and we agreed that is not one-to-one. And we know that this graph just keeps repeating over and over again, right? So with our trig functions, what we have to do is take a section of the graph. If I only looked at this piece of the graph, I drew that for you a second ago, and we agreed that was one-to-one because the y's didn't repeat there. So when we're dealing with the trig functions, we have to restrict the domain. Whoops. We're not going to look at everything. We are going to pick two consecutive quadrants. All right, we need to capture a piece of this graph, a consecutive piece, where it hits the positives and the negatives. Now we know all four of them are positive in quadrant 1. So for the second piece, the second quadrant, we'll either use quadrant 2 or quadrant 4. Okay, if you think about your 4 quadrants, we're taking quadrant 1 no matter what. We need consecutive quadrants, so that's either 1 and 2 or 1 and 4. Those would touch. We will never ever use quadrant 3 when we're talking about inverses because we need one complete section of our graph, and that wouldn't connect to quadrant 1. Does that make sense? So what we really have to know with these inverse trig functions is which quadrant we are dealing with. And that will be the one piece. We're going to go through all 6 trig functions. I'm going to show you the graphs. I'm going to talk a little bit about the domain and range, but what you really need is the quadrant piece for each of these. So if you have a highlighter, you might want to grab that so you can just kind of identify on your notes what you really need to know moving forward. So the first one, inverse sine. You might see a couple different things, sine to the -1, or sometimes you'll see arc sine. ACT likes to use arc sine a lot. They mean the same thing, it's just the inverse. So if we think about the normal sine graph, its range is from -1 to +1. So that becomes the domain on the inverse. The range, we have to take a restricted piece. Okay, if you think about sine, it's positive in 1 and 2. I need a quadrant where it's positive and one where it's negative. So I have to pick quadrant 1 and quadrant 4. Does that make sense? So, what you really need to know when you have inverse sine in your problem, you are either in quadrant 1 or quadrant 4.
If you have what?
It's quadrant 30.
Hmm?
But in that, it's quadrant 1 and 30.
You mean when I say this, or?
No, like when you look at the little...
So, we're going to work problem. We have actually done problems similar to these before. The thing was, we never started with an inverse. When I look at an example, and it starts out with either sine inverse or arc sine. So if the original problem has an inverse in it, that means my answers are restricted. As soon as I see that, I know arc sine or sine inverse can only be in either quadrant 1 or 4. I am not looking at the entire circle. It was an inverse, so I only have 2 possible quadrants. Then I look at this number. 1/2 is positive. So in which of these quadrants would it be positive? Quadrant 1. So I'm giving an answer in quadrant 1. So all of this means, it's like saying sine of what angle would equal 1/2? So when is sine 1/2? 30 degrees. Since we're in quadrant 1, 30 degrees is quadrant 1, so that's our answer. If I asked for it in radians, what would that have been? Pi over 6. I will specify in the directions which one I wanted. I could ask for either. You will not have to just list both. I'll say either degrees or radians. So that is my answer. sine inverse -1. So as soon as I see sine inverse, I know I am not looking at the entire circle. Sine inverse had to be quadrants 1 or 4. If it's a negative, it would be quadrant 4. So I'm just asking, when is sine -1? This is where the unit circle can be helpful to you. If you have a circle filled out, we know we're only looking at quadrants 1 or 4, so we're only looking at this half of the circle. Sine is the y, so I'm trying to figure out where on that half of the circle does y equal -1. And when does that happen? 270 degrees. If I asked for radians, what would that be? 3 pi over 2. Just as a heads up, your book will typically, instead of saying 270, say -90. And instead of 3 pi over 2, negative pi over 2. I don't care. Do you guys recognize that these are coterminal? If you take -90 and add 360, you get 270. Negative pi over 2 plus 2 pi is 3 pi over 2, so I don't care. Just recognize that when you're looking, if you're checking the answer in the book or looking at an example, they will do the -1. But they're the same, so I don't care. Sine inverse of -2. So sine inverse, I know that could be a quadrant 1 or it could be a quadrant 4. How do I pick my quadrant? Right. Since it's a negative for quadrant 4. So this is sine of something is -2. So we're looking at our unit circle. When does y equal -2? It doesn't. The biggest it can be is it has to fall between -1 and 1. So this one is no solution, does not exist. It never equals that value. So what you have to know is which quadrant you can answer in, and then you will get a single answer on these inverse questions. Okay, let's talk about cosine. So if we think about the cosine graph, if you just went from 0 to pi, that's quadrant 1 and 2. Quadrant 1 is where it's positive and cosine is negative in quadrant 2. So that would work for my inverse. So inverse cosine, I put all this stuff on here. It's from your book, but really I'm not going to ask you to graph these. I'm not going to ask you to list the domain and range. What I'm going to ask is if it's cosine inverse, what quadrants can you be in? Cosine is positive in quadrant 1, and we need a negative quadrant. It's negative in quadrant 2. So that's what you need to know here. Cosine inverse can be in quadrants 1 or 2. I think on your handout I did have you like filling in the blanks. So domain and range, I think I've left those blank for you to write in. But again, I'm not going to specifically test you on that. It's just the domain because regular cosine only falls between -1 and 1. The range, we're only going from 0 to pi. So that becomes the range in the inverse. So let's try some examples. So when I see this, arc cosine, that's cosine inverse. I know cosine inverse can only exist in quadrants 1 or 2. Because this is a positive 1, which quadrant do we need? Quadrant 1. So the question is, all this means is cosine of something equals 1. When does cosine equal 1? At 0 degrees or 360 degrees, 0 radians or 2 pi radians, those are all the same. Next one. Cosine inverse of negative radical 2 over 2. So as soon as I see cosine inverse, I know I can be in which quadrants? 1 and 2. If it is negative, which quadrant? 2. Okay, so this means cosine of something equals a negative radical 2 over 2. When is cosine radical 2 over 2? 45 degrees. What's 45 degrees in quadrant 2? 135. If you're looking at your circle, you're looking in quadrant 2, and when your x was negative radical 2 over 2. If I ask for it in radians, 45 degrees is pi over 4. What's pi over 4 in the second quadrant? 3 pi over 4. So again, if you're struggling with knowing these values, then let's practice filling out the unit circle, and you could fill out your unit circle every time and use that to look at and base your answers off of. Another one, cosine inverse of 1/2. So cosine inverse means quadrants 1 or 2, but it's positive, so that's quadrant 1. So all this means is when is cosine 1/2? 60 degrees. Since we're in quadrant 1, that's our answer. Or if I said radians, it would be pi over 3. Any issues so far? So the next 4 functions, we're just going to quickly kind of go through them. Again, I've got space for you to write down the domain, the range, and the quadrants, but all you really have to know is the quadrants. So if we think about tangent, we know it's positive in quadrant 1. It's negative in 2 and 4. So we have to think a little bit. When we graphed tangent back in chapter 4, we picked a weird interval for it. Where did we graph it? From negative pi over 2 to positive pi over 2. So when we graphed tangent, we used quadrant 1 and 4. So that's what we're going to use for the inverse on it. So domain is the range of regular tangents, so negative infinity, positive infinity. The range is the domain we're looking at from negative pi over 2 to positive pi over 2. What we really need to know is its quadrants 1 and 2. Sorry, I said 1 and 4, and then I just wrote down 2. Sorry, quadrants 1 and 4. Okay, when we graphed cotangent, what interval did we use to graph it? We went from 0 to pi for it. So that's quadrants 1 and 2. So inverse cotangent, again, your domain and range, but what you really need to know is quadrants 1 and 2. Secant and cosecant match what we did for sine and cosine. So the first one I have on here is secant. Secant is the reciprocal of cosine. So which quadrants did we use for cosine inverse? 1 and 2. So secant inverse will also be quadrants 1 and 2. It does have asymptotes in it, that's why your domain looks a little bit weird. But again, that's not really what I will ever test you on. So cosecant has to do the same thing as sine. What quadrants do we use for sine? Sorry. The last one, cosecant inverse is 1 and 4. So I said find the degree measure of theta. Alright, so when I see arctan or tangent inverse, I automatically know it has to be in which two quadrants. But this is a positive, so which quadrant would that be? 1. Okay, so all this means is tangent equals 1. When is tangent 1? If you think about your hand trick, that's when the square root of the top over square root of the bottom. When is that 1? 45 degrees. Since we're in quadrant 1, do I have to do anything else to it? So it's just 45 degrees. What if we had had negative 1? What would my answer have been? 135, because you would have had to put it in quadrant 2, so 180 minus that. Oh, dang it. I don't know why I wrote 2. Sorry. I think I looked down at the secant here when I was writing that. My goodness. So if it had been negative 1, what would our answer have been? And we'd have to put that in quadrant 4, so 360 minus 45, 315. Nothing like confusing you on the first day. If I could do what I say, that would be great.
If nobody ever said anything, I would have probably.
What they say?
I wrote down quadrant 2 at the beginning, but tangent inverse is 1 and 4.
Yeah,
Oh,
it's up there on the board, and I was like.
Yeah. Sorry, it's Monday, guys. We all get extra allowance on Monday, right? Okay, secant and cosecant, a lot of times that's harder for us to think about. If you struggle with that, you are welcome to rewrite this. Secant is the reciprocal of what? So this is just like saying cosine inverse is 1/2, if you just want to do the reciprocal. So if you like sines, cosines better, you could do that. When I'm looking at secant, I know it has to be in which quadrants? 1 or 2. It was a positive, so that's quadrant 1. Reference angle, or sorry, our actual angle here. What this means is that cosine from our angle is 1/2. So when is cosine 1/2? 60 degrees. Since we're in quadrant 1, that is my answer. If I were in quadrant 2, you'd have to do 180 minus that. So far, so good? The one thing I want to discuss, sometimes I might give you angles that aren't on the unit circle, so we have to use our calculator. The calculator can be dangerous. When we use this, never enter a negative angle. Here is why. The issue really comes up with tangent and cotangent, because do we have a cotangent button? No, so we would have to use the tangent button. But tangent inverse, if you put in a negative, will give you an answer in quadrant 4. But if we started with cotangent, we'd really need an answer in quadrant 2. And so our answers will be wrong. So instead of trying to remember when I can and when I can't use the negative, I will just say we're never going to put in the negative. We'll just do a reference angle by putting in the positive, and then we'll put it in whatever quadrant we need. So let me do an example or two to explain what I mean by that. So find y in radians if y equals cosecant inverse of -3. So, cosecant, which quadrants can we be in? 1 or 4. Because this is a negative, it's quadrant 4. All right, do I know when cosecant is 3? That means sine would be 1/3. Is that something we know? No. Okay, so this means Cosecant is -3. So here's what we're going to do on the calculator. We have to, first of all, we need to be in radian mode. So make sure you are in radian mode. We have done problems like these before. We have to do sine because we don't have a cosecant. But we have to think about how we're going to put that in. If cosecant is -3, that means sine is what? So you are going to do sine inverse of +1/3. So you hit second sine 1/3. What that gives us is our reference angle. I want that in quadrant 4. So we know that this little angle is 0.3398. I need the whole thing. What would you have to do? Right, subtract from 364 degrees, but we're in radians, so we'll have to do 2 pi minus that. And so we get 5.943. Does everybody understand how we got that? B. Find theta in degrees. So if I'm in degrees, we need to switch our mode over to degree mode. I see cotangent inverse. That tells me which quadrants. But it's a negative, so that's quadrant 2. So what this means is that cotangent of theta is -0.3541. If I'm going to put it in the calculator, we have to use tangent. Tangent is the reciprocal. So what we're going to do on our calculator is tangent inverse of 1/, but do the positive. This is the problem where if you put in a negative, you will get the wrong answer because tangent inverse is different quadrants than cotangent inverse. So we hit second tangent 1/0.3541. Okay, that gives me my reference angle. How do I put that in quadrant 2? And you don't necessarily have to show this much work, but I'm trying to show you exactly where my answers are coming from. So we get 109.4991 degrees. So I'm telling you to find this without using a calculator. And I have two things, a sine of tangent inverse. The answer to an inverse problem is always an angle. So when I say tangent inverse 3/2, that means tangent from some angle equals 3/2. If I'm looking at tangent inverse, what quadrants can we be in? But it's a positive 3/2, so that would be quadrant 1. So I'm going to draw a triangle. Okay, we're in quadrant 1. Tangent is opposite over adjacent. How would you find your other side? 13, so this side is the square root of 13. So now, we didn't never actually find this angle, but we know that inside piece represents an angle. So all I have to really do is find sine of that angle. Can I use my triangle to find sine? Opposite. Mhm. So that's 3 over the square root of 13, or 3 radical 13 over 13. So tangent of cosine inverse of negative 5 over 13. We know the answer to an inverse is really just an angle. So ultimately, we just have to find tangent from that angle. Cosine inverse of negative 5 over 13 means cosine from some angle is negative 5 over 13. Cosine inverse can be in which quadrants? But if it's a negative, we're in quadrant 2. So that's where we set up our triangle. Cosine is adjacent over hypotenuse. We know the hypotenuse is always positive. So then we can do Pythagorean here. Will it be a positive or a negative? Positive because we're going up. We did. So from this angle, tangent, opposite over adjacent,